What chemical reaction makes a cold pack drastically drop temperature? Imagine holding a cold pack and feeling it suddenly become icy cold in your hands. Have you ever wondered what kind of chemical magic makes that happen? Well, it all comes down to a special kind of chemical process called an endothermic reaction. This is a process that absorbs heat from its surroundings. When you activate a cold pack, you usually break an internal barrier that keeps a solid chemical, often ammonium nitrate, separated from water. Once broken, the solid dissolves into the water. This dissolving process requires energy to break apart the ionic bonds in the ammonium nitrate crystals. That energy comes from the water and the cold pack itself. As the bonds break, heat is taken away from the water, causing the temperature to drop quickly. This is not a typical chemical reaction where new substances are formed. Instead, it is a physical change called dissolution. When the ammonium nitrate dissolves, the water molecules surround the ions, pulling them apart. This process absorbs heat from the environment, making everything feel cold. From a thermodynamics point of view, the stored chemical energy in the solid is converted into a heat transfer process that cools down the surroundings. The system's enthalpy, or heat content, decreases during this process. That is why the cold pack feels so icy. Other chemicals like barium hydroxide mixed with ammonium chloride or ammonium thiocyanate with barium hydroxide can also produce similar cooling effects. These reactions are also endothermic, meaning they absorb heat and cause temperatures to drop as low as -18 degrees Celsius. But ammonium nitrate is the most common because it works efficiently and is easy to find. So, the big temperature drop in a cold pack happens because of the endothermic dissolution of a salt like ammonium nitrate in water. This process pulls heat from the surroundings, demonstrating how chemical energy can change into thermal energy through heat transfer. It is a simple yet fascinating example of how chemistry and thermodynamics work together to produce that instant cooling effect we relying on in injuries or sports.